All right, chapter 4-5, we're going to take everything that we have learned from the last two sections, which is 4.3 and 4.5, and really even before that when we were simplifying expressions. All of that is culminating or kind of coming together for this last section that we're going to do in 4- or in chapter 4. Okay, so this is going to be solving two-step equations. Now I added a blank page here at the bottom so I can write. You're going to do this in steps, and I want everybody to write these steps down so that you can refer back to them when you're working on this. Okay, so the steps are step 1, and especially on Khan Academy, this is where this will really come into play, but distribute if you have, and I'm just going to put parentheses, right? So if you have parentheses, everybody is going to have, when I do a note check, I'm looking for these steps, okay? So if you have parentheses, and we know how to distribute because we did that in 4.1 and 4.2. Noah, you should get a piece of loose leaf paper. Remember, we talked about that yesterday, huh? As long as there's no perforation. All right, step 2. Actually, does it have the perforation where you can like fold it and get all that off of there? Yeah. Okay, make sure that happens. All right, step 2 is to combine like terms on each side of, I'll just put the equal sign. Step 3 is to add or subtract as needed. And then step 4 is to multiply or divide as needed. And really all these are as needed, but. So if you have a problem with parentheses, the first thing you're always going to do is get rid of parentheses. Then, and this is where, remember I told you on that first day of solving equations, I said I always use the wall. This is, and I told you when we get into the more complex equations, you'll see why the wall is so important. So you're going to combine like terms on each side of the equal sign or on each side of the wall. Then you're going to start adding and subtracting and multiplying and dividing. Okay. Does everybody have that? If not, leave a couple spaces in your notes. And when you have some downtime, go back and just turn on the video to this point, pause it, and add it to it if you need it. Okay. All right. So we're going to go through these 4 steps. Okay. The first couple are going to be pretty basic. So we'll do example number 1. PQ plus 22 equals 10. And again, on every single one of these, notice your instructions, okay? Solve each equation, check your solution. So this is just like 4.3 and 4.4, where you have got to solve it. Then you've got to plug in your answer for the variable, get it all the way down to where, in this case, like for number 1, we would need to get it all the way down to 10 equals 10 to call it checked, okay? All right, so step 1 was distribute. If we have parentheses, we don't. We can skip that. Step 2 is to look for like terms on each side of the equation. Okay, so again, remember this is kind of like a wall. Do we have anything on the left that we can combine? We have a term and we have a constant. Can we combine those two? Nothing over there to combine. There's just a single 10 over on the other side, so we can skip step 2. Step 3 is to add and subtract. Well, this is just a silly memory trick, okay, but I throw it out every year when I teach algebra, and it typically helps with remembering the order. The 6 and the P, how are they attached? Multiplication. Okay. If you think multiplication is like marriage, right? When you get married, you become one. So right now, the 6 and the P are one term, right? They're tight bond. They're married, right? They're multiplied. The plus 22 is like when you have kids, right? They're not quite as attached. Eventually your kids are going to move out. They're going to get their own apartment. They're going to get married. They're going to move away. Okay. So if you think about the 6P as a really tight bond, it's going to stay together to the very end. The plus 22 is the easier one to break off or the easier one to move. So we always move the plus and the minus first, and we leave the tightest bond to be the very last one we break. So in this case, we've got a 6 and a 22 on the left-hand side with our P. We know that both of those numbers have to be gone eventually because we need P by itself, and we always break the easiest one first. So if we have a plus 22, the first thing we're going to do is minus 22. And again, with everything from this point on, whatever we do to one side of the equal sign, we have to do to the other. Okay, the distribute, you don't do that to both sides. The combining like terms, we'll get to that, but you don't move things left and right on both sides. It's only when you get to the add, subtract, multiply, and divide where your wall comes in and you make sure you're fair and you do everything on both sides. All right, so when we move that negative 22 over, we end up with 6P over here because we haven't done anything with that yet. And then on the other side, remember adding and subtracting integers, you got to really keep your rules straight here, but we've got a plus 10 and a negative 22. So we subtract the two numbers and we get a 12. Now, am I going to make it positive 12 or negative 12? Negative, because the 22 carries the negative sign and it's the bigger term. Now is that our final step. We have nothing else over on the side with the variable except the 6. Now it's time to break that strongest bond. It's multiplication, which means we divide and we divide. And when we do that, the 6 and the 6 reduce to 1, or in essence, go away, right? Leaving us with the P. And then on the other side, now we got to switch our brains to multiplication rules. We've got a negative 12 divided by a positive 6, which is negative 2. That's your answer. Now we check it, right? Because with every problem, we have to check it. So checking it means that we have decided that the P is equal to negative 2. So we go back to the original equation where there was a P, and now we write the whole original equation, but in place of the P in that parentheses, we're going to put a negative 2. So we've got 6 parentheses, negative 2, because we're plugging in negative 2 for P, and then plus 22 equals 10. Now think PEMDAS, what do we put together first, the multiplication or the addition? Yeah, we PEMDAS, when we're refiguring things, we do multiplication first. So 6 times negative 2 is negative 12 plus 22, and negative 12 plus 22 is positive 10. So once you get to 10 equals 10, you're checked. As long as you didn't make a sign error, it should come out 10 equals 10 in this case, okay? All right, let's do an example with the division. So we're going to do this example now. I don't see pencils moving. I'm going to wait till everybody gets it written down. The longer it takes you to do that, the less time you have to do your homework. All right, so again, always take a second to kind of look at your problem overall, think what all do I need to move? So I have a variable, there's an R, it's tied up in a division problem with the 3. There's also a -4, and then we have an equal sign. So no parentheses, so we can skip the distribution step. We have a term with a variable and we have a term without on the left, so we have nothing to combine, so we can skip step 2. Now we're ready for our wall. All right, this is where we start doing things on both sides. Multiplication and division, they're the same thing. So that R and that 3, right? They're bound tight. They're in a fraction together. We're not going to mess with that till the very end, which means we're going to move that 4 first. So +4 plus 4. And when we do that, the R over 3 is all that's left over there because that's gone. And then 2 plus 4 is 6. Now we're just left with what we had yesterday, which is a simple, it's tied up in division. So we multiply by the denominator. What we do to one side, we do to the other. The 3 and the 3 reduce to a 1, which is what we wanted. And then 6 times 3 is 18. Okay, now we have to check it. So we're going to go back to our original problem, r over 3. So in place of r, I'm going to put an 18. So 18 over 3 minus 4 equals 2. So we always reduce the fraction first. So 18 over 3 is 6 minus 4 equals 2. And 6 minus 4 is positive 2. So it checks out.
Kane Thompson to the office to leave. Kane Thompson to the office to leave.
All right, so now I want to go to a little bit more complex problem because I think these are going to be the ones we're going to do a couple of examples. So we're going to do number 17 first. Got it written down, Robert? Number 17. All right, think through our steps. Step 1 is distribute. There are no parentheses here, so we can skip that step. Step 2 is to look for like terms on either side of the equation that we can combine. Okay, now if you think about our wall here, on this step, you are not moving things on the other side of the wall. And here's where I have a lot of students make this mistake. So I'm gonna say it once as a mistake, but I don't want you to put this in your notes, okay? What I have a lot of students wanting to do is they want to subtract 5y and subtract 5y, okay? Now, if you look at our equation, and remember I said the equal sign is always the center and it's always the scale. What have I done? I've done 2 negative 5s on the same side of that scale, so I have completely offset my scale. Because the only time that you're going to subtract and subtract is if you do it on each side of the scale. Yes. That's what we're going to do. I'm just kind of going through what the typical mistake is just to kind of help you be very mindful to not do it. Okay. That's why I said I don't want you to write this down right now. I just want you to listen. The mistake I see a lot is everybody wants to do -5 and -5, or not negative, sorry, +5 and +5. Hang on. Sorry, they want to do a +5y and a +5y because they want to try to make this 5y go away, right? But you cannot do that because you have done 2 + 5y's on one side of the scale. Yes, you're getting your y's together, but you're doing it by a math foul of you're doing 2 operations on one side of the scale and nothing on the other. So you have now tipped your scale and you've changed the value of your equation, okay? So instead, when they are already together on the same side of the equation, what Gage said, right? They're already on the left together. They're already in that basket. I'm just writing them in a more concise way, or I'm simplifying them. And that's where the whole day 1 and day 2 of chapter 4 comes in, that we were simplifying expressions. We just want to simplify this half of the equation like an expression, okay? So that means combining like terms. So we've got a 9y and a -5y that we can combine. And remember, when you combine like terms, you just add or subtract their coefficients. So 9 minus 5 is 4y, right? That combines my 2 y's. I didn't do anything with that -11. And I've still got my equal sign, and I didn't do anything with my 25. Okay, your equal sign still is your wall. And all we did in this step is combine like terms on the left. Okay, now I'm ready to actually start moving things left and right using the add, subtract, multiply, and divide. So again, we always snap off the easy one first. So I'm going to do +11 and +11. And this is where it's important that you're doing, right? Look at my wall. Do I have it even? I've got to evenly distribute. I've got a +11 on one side of the wall, plus 11 on the other side of the wall. So I've kept my scale balanced. So I'm good there. Negative 11 and positive 11, zero out, which is good. That's what I wanted. Equals 25 plus 11 is 36. Now, the last step is always to break that final bond of multiplication. I'm going, because it's multiplied, I'm going to divide. 4 and 4 cancel out, leaving me a y equals 36 divided by 4 is 9. Now, checking these takes an extra minute, and here's why, okay? Look at my equation. Remember, where I find a y, I'm going to plug in a 9. Well, looking at my equation, there's two different places you could go to plug this in. What do you guys think? In the first equations we did, I just said, go back to your original problem, right? What do you think? Do I have a different option here, Gage? Yeah, you can go back to the original equation. And if you do, you need to plug 9 in both places where you see a y. Or you can save yourself a little bit of work if you go back to here where you've combined it. Right, Lakin? Where would I plug it in there? Huh? In place of the y, yeah, next to the 4. So if you choose to plug it into your second step where it's combined, it's just one less place you have to worry about plugging in a y. You'll get the same answer either way, but it's a little less work for you. So I'm going to go to this step right here, and I'm going to plug in 4 in place of y. I'm going to put a 9 minus 11 equals 25, right? So I'm going to use this step as my plug-in step or my check step. 4 times 9 is 36 minus 11 equals 25. 36 minus 11 is 25, and so it does check out. Now, if I chose to go back to my very original equation before I combine like terms, you would still get the same answer. You would still get 25 equals 25. It's just a little bit more work, okay? All right, I want to do one more like this, and then I want to do one with parentheses, and then we'll be done with notes, okay? Let me look at your homework, because I don't like to do harder ones than you're going to see on your homework. Okay, so we are going to do number 20 as an example, and then we will be done. Yes. 20, the one at the top. Number 20, the one at the top. All right, so first things first, we don't see any parentheses, so we don't have to distribute. The next thing that we need to look at is look for combined, or I look to see if we have anything that we can combine. Now, obviously on the right, there's just an 11 over there, so we're not going to mess with combining. Remember, in this step, we're just combining like terms. We're not moving things left and right. So we're looking for like terms. I have a negative 6h and a, what is the number in front of that h? A 1. So as far as my h's on the same side of the equation, I can combine these. I have negative 6h and positive 1h leaves me what? Good. Negative 5h, right? I'm just combining my h's. Then I also have some constants I can combine. I've got a positive 4 and a negative 3. So what's 4 minus 3? Plus 1. And then equals 11. Now notice, right, I haven't changed the value of my equation. I haven't subtracted things left and right. I've not done anything with my scale movement yet. All I've done is taken everything that was kind of in that left side basket. I've left it on the left side. I've just rewritten it in a little bit more concise way. All right. Now I'm ready to actually think of your scale here as your wall. Now I'm ready to start moving things from one side of the wall to the other. So this is where I do it on both sides. I currently have a +1, so I'm going to -1 on both sides. Okay, when I do that, my +1 and my -1 go away, and I'm left with -5h equals 11 minus 1 is 10. Now I'm ready to break that final bond of multiplication or division. And in this case, it is a multiplication problem. So I'm going to divide off a -5 from both sides. And when I do, I get h equals +10 divided by -5 is -2. Now, again, for checking, right, I'm going to use my combined version right here, because I think that's the most concise, easiest place to plug in. You can plug into the top, but if you choose to plug into the top, you got to plug into both H's. All right. So I'm going to do where I circled there in yellow, and I'm going to say -5 times H, which in this case, I've decided H is -2, plus 1 equals 11. Something's not checking out. What I do? Anybody see it? Oh, yeah, it is. Sorry. I was jumping ahead. -5 times -2 is +10 plus 1. And 10 plus 1 is 11. So I get 11 equals 11. So that means my H equals -2 is the correct answer. These are longer. They do take a little bit more time. Okay, they're a little bit more time. They take a little bit more time, as you do have to combine the like terms. All right, I want to do one example with parentheses because you will see this on Khan Academy. So I want everybody to write this problem down. Your homework will not have any parentheses, but the Khan Academy ones will. So I want to make sure that you have one example in your notes of one with parentheses. Waiting on everybody to get it written down. All right, so in this case, we do have parentheses. So our first step, yes. Yeah, it's 4, and then in the parentheses, x plus 3, and then out of the parentheses, plus 2x minus 2 equals -8. All right, so the first step is to always get rid of those parentheses if you can, and we can because we've got distribution. Lakin, will you stand up, please? Take your notes standing up. That'd be great. Thanks. All right, so when we distribute, 4 times x is 4x. 4 times 3 is +12. And I didn't do anything with the whole rest of the equation, so I'm just going to write it just like it is. That's step 1, that's distribution. Step 2 is combine like terms on either side if you can. Yes. Yeah, perfect. So we've got 4x and 2x that are together, right? They're already over here. So all I'm doing is combining like terms. So I've got 6x. What else can I combine over here? Jaden, what do you think? What else can I combine over here on the left? Well, I've combined my x's. What else can I combine that's alike? Do I have any constants? Yeah. I've got a 12 and a -2. So 12 minus 2 is +10. That's everything combined over there. So I'm going to put equals -8. Now this is where my wall comes in. Now I'm actually going to start moving things left and right, which means I have to do it on both sides of the wall. The easiest thing to snap off is that +10. So I'm going to do -10 because you always do the opposites. Leaves you 6x equals -8 minus 10, 2 negatives when you're adding and subtracting. 2 negatives go deeper negative, so -18. Now your final bond to break is what, Logan? What's the final thing to do? Yeah, it's currently multiplication, so I'm going to divide a 6 off of both sides, and I get x equals negative 18 divided by positive 6 is negative 3. Now, my first problem was a really big problem. I am not using that as my plug-in and check, right? Make it easy on yourself. Go to here, where you combined all your like terms and you've got it as concise as it can be. Plug in there. It's a whole lot easier. 6 times my negative 3 plus 10 equals negative 8. 6 times the negative 3 is negative 18 plus 10 equals negative 8. Negative 18 plus 10 is negative 8. And so it checks out. Okay. All right. For those of you at home, the ones that you are going to do on your homework are going to be all of the ones on the right-hand side of the page. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33. That is it. Okay. Let me know if you have any questions. And if you need me to open up a meeting later on today for any help, I can certainly do that. Just let me know.